Hello and welcome to asynchronous recorded lecture 35 for Bio 145, Microbiology. This lecture is scheduled for Wednesday, April 22nd, 2026. The topic today is fungal diseases part 2. So lecture 34 was rather long. I know that. It covered pretty much all you need to know about fungi and fungal diseases for this class. So just go through it thoroughly and make sure you understand that for the final exam. Today, I'm just going to have a short lecture. I'm going to spend time talking not about fungi, talk about something that you might not have heard about, or maybe you have heard about. It's really interesting, and it's kind of discussed sometimes in microbiology classes. And it's known as prions, which are protein infectious particles. These are literally proteins that cause diseases. So let me go to the next slide, and I'll tell you the story. So we're just going to take a little time to talk about mad cow disease, which has other names, but that's what we'll stick with, which is caused by something called a prion, a protein infectious particle. So here, let me start with the scenario. Let's say there is a very strangely acting cow, as shown in this picture, and it has a disease, but it was butchered, its brain was taken out, and its brain was used to make some kind of food. Okay, head cheese is an example. A person eats that brain and unwittingly eats the infectious particle that was in that brain. Years go by, and the person who ate that brain starts to act crazy, starts to kind of act like a mad cow, loses coordination, has dementia. Sounds like it's impossible, but it's very possible, and that's what happens in mad cow disease. So, in mad cow disease or scabies, basically, the agent we're talking about that's going to cause a disease just causes bad folding. It is a protein that causes other proteins to fold incorrectly. So we say this agent is actually a protein. It's called a prion, and it's called an infectious prion protein, and it's known by PRPSC. All right, PRPSC, because it means prion protein of scabies. And like I said, it's found in the food, it goes in the gut, and it ends up entering brain cells, okay? And so we're talking the food is usually a nerve in the other animal where the PRPSC protein is. So like head cheese, monkey brain, things like that can have this PRPSC. Now, it travels from the gut to the brain, mainly by going through nerves. It's kind of like a retrograde transport, but don't worry about that. So when it gets to the brain, what it does is it binds to a normal protein called PRPC. It's kind of like its cousin protein. And PRPC is a good protein. It's a normal protein. But when it binds to PRPC, when the PRPC, okay, is bound by PRPSC, it converts. So like here in the drawing, here's the PRPSC. It binds PRPC, and now the PRPC becomes PRPSC, this scabies version of the protein, the bad protein. Okay, that's what's going on. So the PRPSC, prion protein, causes a normal protein to fold incorrectly. And now when it folds, it becomes a new PRPSC. All right, let's go to the next slide. So in this slide, on the left side, we have PRPC or cellular PRP. It's like the normal good protein. That's what it looks like right here. Okay, and when it becomes PRPSC, it's the same protein, but it's been refolded and misfolded, so it's evil. So here is PRPSC, which is our prion protein that we think of when we think of the mad cow or the scabies disease. As you can see, it's just same protein, but it's been folded differently. So now it acts differently. And once it goes from PRPC, the normal, to this form, now it can cause other proteins to change. Let's get to that next slide. So Now you got to understand vampires. You know about vampires, like there's a vampire and it bites you, you become a vampire, and then you turn around and you bite other people and they become vampires, and pretty much everybody's become a vampire after that. That's what's going on here. So what I want you to think about then is that PRPSC, it goes into the it goes in the brain, it causes misfolding of PRPC, and now you have a lot of PRPSC. So like now here PRPSC, and then soon this guy goes to this one here, and now we have a lot of PRPSCs now. A lot of these prion proteins, PRPSC. Now the problem is PRPSC, all right, they clump together in the brain and they end up messing up brain function, all right, and soon, well, give enough time, there's an effect and the brain cells don't work well, and then you get the symptoms and signs. So what are the symptoms and signs? Okay, a person with this disease, mad cow disease, scabies, they lose coordination, they start to have dementia, all right, and again, like I said, it's called scabies in sheep or mad cow disease in human and people. And it basically is incurable. Once it gets to the stage where you're having this dementia, lack of coordination, nothing can be done for you. Your brain is shot, and it's just going to get worse and worse as more and more of these PRPSCs, more and more of these prion proteins are there, and they just make the brain worse and worse until you die. So prions, I just want to emphasize, they're purely protein. They're purely protein, okay? There's no nucleic acid in there, all right? They come in, they enter a cell, and they change the folding of other proteins. And then once they're eaten, okay, like that brain show's eaten, they go into another person, they go from the gut, and they get the brain of the new person, the new host, and they cause the same thing to happen. These guys are really tough. Okay, you're like, well, in food, well, they're proteins, right? Shouldn't they denature when they're cooked in food? Well, actually, these proteins are really tough. They can survive, like we're talking like cooking. They can survive, exposure to radiation. They a lot of proteases that should chew them up. They don't chew up prion proteins. Normal cooking does not deactivate it. And that's why you're not safe if you eat something that you say, well, it's got prions in it, but it's cooked. That doesn't help. All right. And I just want to note that the incubation time is a long time from consuming it to actually having symptoms of like, movement problems, dementia. It takes 8 to 12 years. And once you develop the symptoms, there's nothing that can be done. Here's actually up here, they got a thing of the brain that's shown of someone who has a mad cow or scabies disease, and he's got these vacuoles. These should not be showing up. They're just a real mess, all right. And these accumulation, you can see like accumulation of here. A lot of these things are supposedly like actually just bunches of that PRPSC, prion protein clumping together. It just messes up brain function. And just here's some sad pictures of hosts that have mad cow and scabies. So here's a cow. Got a cow here in the top picture. It can't stand up anymore. Its brain function is just greatly marred. It's really, really sad. All right. Well, unfortunately, before they really knew what was going on, they would take cows like this and their brains, grind them up and put them in food. And that's how this got spread. Okay. They've stopped doing that. And the bottom here, there's a sheep, and you can see all of their wool has been scraped off. And this is where we got the name scabies, that when they have this brain problem, they just have this uncontrollable urge to like rub themselves, scrape themselves against so bad that they lose all their wool. So that's how they got the name scabies. I don't have a picture of a person with mad cow disease because that would be really, really sad. But now that's why they've made rules where they try to very much control. If they ever see an animal, a cow or a sheep that has scabies or mad cow disease, those are not allowed to be used in food making because that scabies protein, it's tough. If it gets in food, it can end up getting in your body and causing the same disease, which would be a real shame. All right, well, that's it for the day. Take care. Be careful what you eat. Bye-bye.